We're here at AUSA 2018 and I'm speaking with Dion Anglin, Director of Defence, Cummins Incorporated. Dion, we're standing beside an example of Cummins Advanced Combat Engine. Could you tell us a little bit about the engine and the thought processes behind the development of it?
Sure. This is a Cummins engine for a TARDEC-funded program called the Advanced Combat Engine. We won this contract in 2015. It's designed for combat vehicles. It's an opposed piston engine. It's a 14.3 liter engine at 1,000 horsepower, designed for combat vehicles similar to the Bradley or the next generation combat vehicle to be used in future vehicles.
And technically, could you explain a little bit about the opposed piston approach and the benefits of it compared to the more conventional engine?
Sure. So one of the things you'll see from this design, it's more of a box shaped than a conventional engine, so it fits nicely into a combat vehicle like a tank or an armored fighting vehicle. So the shape alone allows for commonality of multiple vehicles. The opposed piston engine technology it's not new technology, but it's been advanced over the last couple of years, and Cummins and Acades Power have been a leader in that innovation of that. And the pistons work toward each other. So it's a single cylinder with two pistons, one on each end of the cylinder, and they work toward each other to compress the gas and do the ignition, and then the pistons return. And so that allows more of the box-shaped than the traditional diesel engine.
And if we took a normal engine that occupied around about the same floor space as the Advanced Combat Engine, what improvements in power output might you have with the Advanced Combat Engine?
Sure. So what we've seen is improvements in fuel economy, about 25%, and also heat rejection, about 25% improvement over the incumbent engine that's being used in these vehicles. And this has been proven in a test cell with a single cylinder engine that's been tested by Acades, and our test will be done here this month with our engine.
And this engine is 4 cylinders and 14.3 litres. 14.3 litres in a straight or a V would probably have 6 to 8 cylinders. This is 1,000 horsepower. What might you get out of a comparable 14 litre 6-cylinder engine, say?
So just an example, our other Cummins engine, the V903 engine, it's been a workhorse for the U.S. military for many, many years, and will continue to be a workhorse for them into the future. That's a 14.8 liter engine, and we currently take that up to 750 horsepower. And this is a smaller engine, 14.3 liter engine, that goes up to 1,000 horsepower. So just comparing the size of the engine and the horsepower, you're getting a significant advantage with this ACE engine.
And where is this engine destined for? Is it on contract to be put into anything in particular?
Yeah, so right now, again, it's a funded program by TARDEC. So Cummins is being paid to move this program forward. In 2019, we'll deliver 2 engines to TARDEC for their testing. That'll get dropped into a Bradley fighting vehicle, mated up with a transmission. That vehicle will be tested with this power pack, and they'll use this as a platform for evaluation of the next generation combat vehicle for the future, and other combat vehicles like it.
And moving forward, are you looking towards developing larger versions of this for possible main battle tank application?
Yeah, it's a great question, because everybody continues to want more horsepower. And so what we've looked at is, this is a horizontal version, so the military's also looked at a vertical version as well as a 6-cylinder. And all those are being discussed and have potential for funding in the future. And the 6-cylinder would be targeted about 1,500 horsepower.
Excellent. Thank you very much.